Hi everyone, this is Ms. Morales, and I will be teaching you about complement of a set. So through this video, you will be able to identify the complement of a set using the notation method and illustrate the complement of a set using Venn diagram. But before that, let us define what is a complement of a set. So for any set A, its complement is the set of all the elements in the universal set that are not found in set A, where A is a subset of the universal set. And it is usually denoted by A raised to the power of C, which is read as A complement. So for better understanding, let's have some examples. Given universal set which has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 as its elements, and set K which has 2, 4, 6, 8, 9, and 10 as its elements. So find K complement. So again, our elements for the universal set, we have numbers ranging from 0 to 10. And for our set K, we have 2, 4, 6, 8, 9, and 10. So our K complement are the elements in the universal set that are not found in our set K. So we have for K complement 0, 1, 3, 5, and 7. Now let us illustrate our answer using a Venn diagram. So note that our set K is a subset of our universal set. And again, for our universal set, we have numbers ranging from 0 to 10. And for our set K, we have 2, 4, 6, 8, 9, and 10. So the elements inside the set K must be the elements of set K, and the remaining elements of our universal set that are not in K must be written inside the universal set but not inside set K. So for our K complement, we have 0, 1, 3, 5, and 7. Why? Because again, our K complement is the set of all the elements in the universal set that are not found in set K. So, as our final answer, we have the complement of set K, 0, 1, 3, 5, and 7. Now, let's take another example. Given universal set which has distinct letters in the word generation, set S which has distinct letters in the word nation, and set L which has R, A, C, I, and O. So find S complement, the complement of the union of set S and L, and lastly, the complement of the intersection of set S and L. So for this situation, the first thing that we need to do is to identify the elements in the universal set and as well as the elements in our set S. So since we already have the elements of our set L, we don't need to identify it anymore. So again, for our universal set, we have distinct letters in the word generation. So when we say distinct, the letters or the elements should not be repeating. So even if there are two E's and two N's, then we will only write one for each of the letters. So the elements of our universal set are we have G, E, N, R, A, T, I, and O. And for our set S, the same concept, distinct letters, we have N, A, T, I, and O. And again, for our set L, we have R, A, T, I, and O. Now, let's identify what is our S complement. So again, our S complement are the elements in the universal set that are not found in our set S. What are these elements? So we have G, E, and R. So you can see the letters G, E, and R are not found in set S but are found in our universal set. So that is our S complement. Now let us illustrate our answer for S complement using a Venn diagram. Note that our set S and L have elements in common, and these are A, T, I, and O. So this is what we call as their intersection. And for the remaining elements of our universal set, like G and E, which are not found in our two subsets, so we are going to write them outside the circle, but inside the universal set. So our S complement then has G, E, and R as its elements. So as you can see in our Venn diagram, these letters G, E, and R are part of our universal set but are not part of our set S. So our final answer for S complement are G, E, and R. Now let us identify the complement of the union of set S and L. So we have there our given for universal set S, and set L. Now, the first thing that we need to do is to evaluate the operation inside the parenthesis before looking for its complement. So, we have there union of set S and L. So, we copy the elements of our set S, the operation as well, and the elements of our set L. So, since the operation is union, then we need to combine the elements of our set S and set L. Take note that the elements should not be repeating. So for our union of set S and L, we have N, A, T, I, O, and R. Now, for the complement of the union of S and L, we need to find out the elements in our universal set that are not found in the union of S and L. So we have letter G and E. So again, G and E are part of the universal set, are elements of the universal set, but are not elements of the union of our set S and set L. Now let us illustrate our answer using a Venn diagram. So the first Venn diagram being shown is our original Venn diagram for the given data, and the next Venn diagram is the union of our set S and set L. So the shaded part there are the combination of our two sets. So that is S union L. Now, since we are going to identify its complement, then what do you think are the elements in the universal set that are not part in the union of S and L? So we have this shaded area. So based on the original Venn diagram, the complement of the union of our two subsets, S and L, is the set of G and E. So again, G and E are elements of our universal set but are not part of the union of our two subsets. So now we will identify the complement of the intersection of set S and set L. So we have there our given, and the same process we did a while ago, we will evaluate first the operation inside the parentheses. So this time the operation is intersection. So we will copy the elements of our set S, the operation symbol, and the elements in our set L. So what do you think are the elements that are common in two sets? So we have A, T, I, and O. So that is our intersection for the two sets. Now since we are looking for its complement, then what are the elements in the universal set that are not found in the elements in the intersection of set S and set L? So we have there G, E, N, and R. So again, as you can see, these letters G, E, and R are found in the universal set but are not found in the intersection between set S and set L, since the intersection between set S and L are A, T, I, and O. Now let us illustrate our answer for the complement of the intersection of the two sets, set S and set L, using a Venn diagram. So the first Venn diagram being shown up there is the original Venn diagram for our given data. And as you can see, the elements in their intersection, or the elements they have in common, are letters A, T, I, and O. So the second Venn diagram is the intersection of S and L. So again, the elements involved in that shaded area are A, T, I, and O. Now since we are looking for its complement, the complement of the intersection of two sets, what are the elements in the universal set that are not involved or that are not part in the shaded area? So we have G, N, R, and E. So the letters G, E, N, R are found in this shaded area on the next Venn diagram. So as you can see in the middle, it is not shaded anymore because it is not the complement of the intersection. It is the intersection itself. And the shaded area is the complement of the intersection. And so for our final answer, we have the complement of the intersection of set S and L. We have letters G, E, N, and R. So again, these letters are part of the universal set but are not part in the intersection of the two subsets. So, am I clear? And now it's time for you to do some practice exercise. So get a sheet of paper and answer this one. So given universal set which has 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 as its elements. Set A which has 1, 3, 5, 7, and 9 as its elements. And set B which has 2, 3, 5, and 7 as its elements. Find A complement, the union of A complement and B complement, the intersection between A complement and B complement, and lastly, the complement of the union of set B and set A. So that's it for this video. I hope you have learned a lot. Thank you for listening and for viewing as well. So this has been Miss Morales saying, love mathematics so that mathematics will love you back. Thank you.